Okay, so let's have a look at the Leaving Certificate Higher Level Maths Paper 2 for 2018, and we're going to look at question 2. So we have a standard normal curve here, and we're told that the shaded area represents 67% of the data. Find the value of Z1. So the probability of appearing in this part of the graph here is 0.67, or the probability of being less than Z1 is 0.67. We've just got to work backwards to find what Z1 is. So what we've got to do here is just look up 0.67 in our tables. So I have these tables here, and if we look for 0.67 in this part of the table here, we'll find it here, 0.6700. And if we look across, we can read off the Z value. Here it's 0.4, and here it's 0.04. So our Z value then is just simply 0.44. So in other words, we can just say here that Z1 here is just equal to 0.44. And that's it really, that's our Z1 value. So the probability of, in other words, we could say the probability of Z being less than 0.44 is going to be equal to 0.67. So this is our answer here. Okay, let's have a look at part B. The percentage results in a maths exam for a class had a mean mark of 70. So let's just write these down as we go along. So we're talking about a mean of 70. Actually, let me just write down, talking about maths here. So this is a mean of 70 with a standard deviation of 15. So we're talking about a standard deviation of 15. The percentage results in an English exam, so this is English, had a mean of 72. So we're talking about a mean here of 72 with a standard deviation of 10. The results in both exams were normally distributed. So first of all, Mary got 65 in maths, so this is our X value. She got 65, and she got 68, this is our X value here, so she got 68 in English. In which exam did Mary do better relative to the other students in the class? Justify your answer. Okay, so really what we've got to do here is work out Z values for both. So if we take maths, we can work out, we know that Z is equal to our X value minus the mean divided by the standard deviation. It just tells us how many standard deviations this X value here is going to be from the mean. So Z here is going to be, for maths, is going to be the 65, which is our X value, minus the 70 divided by standard deviation, which is 15. Now when you work that out for maths, you get minus 1/3, or minus 0.33, 3 repeating here. Let's have a look at English. We do exactly the same for English. So our Z score here is going to be, the X value is 68, so it's 68 minus 72 divided by the standard deviation here, which is 10. Now when you do that, you get minus 0.4. So we can already see that 0.33 is bigger than minus 0.4. So she did better in maths. Now, just to explain that a little bit further, we can work out probabilities. I'll do that in a minute, but if you think about it, if you have your standard normal curve and we've converted these to Z values, so this is 0 here, we have minus 0.33 and we have minus 0.4. So let's say this is 1 standard deviation here, minus 1 standard deviation. So we're looking at minus 0.3, let's say there, and minus 0.3 there, minus 0.4 here. So let me just write that in, minus minus 0.33 would be here, and minus 0.4 would be here. So we can see that she's further to the right, if you like, along the scale here in maths. So she did better in maths than she did in English relative to the other students. Or if you want to look at it from the point of view of probability, we could say, let's see, the probability that Z is less than minus 0.33. We can work out the probability here. That's just going to be now if we just draw this again, if we have 0 here and we have minus 0.33 here, now we want the probability of being less than that, so down here we can't look up negative numbers in our tables anyway, so we need to look at plus 0.33. So we need to look at the equivalent area up here. But again, our tables don't give us greater than values, they only give us the probability of being less than a particular Z value, so down here. So really we need 1 minus the probability that Z is less than plus 0.33. So we can look this up. We can look up 0.33 in our tables. So again, if I go to my tables here, we can look up 0.3 and 3 here. It's 0.6293 here. So this is just 0.6293. If I subtract those, I get 0.3703. In other words, 37% of the students are lower than her here. 37% of the students are below her score. So here 37.03% of students scored less in, this is maths. So 37.03% of the students scored less than her in maths. If we do the same for English, we can work out the probability that Z is less than minus 0.4. Same kind of idea here, I won't go through it all again, but it's just going to be 1 minus the probability that Z is less than plus 0.4. Again, we can look this up in our tables and you get 0.6554. 0.6554 here. If we do the subtraction here, we get 0.3446. So in other words, in this particular case, 34.46% of students scored less in English. Therefore, she did better in maths. Relative to the other students. Okay, so that's what we were asked to do here. Mary got 65 in maths, 68 in English. In which exam did she do better relative to the other students in the class? Justify your answer. So we've done that here. Okay, so let's have a look at part 2 here. In English, the top 15% of students were awarded an A grade. Find the least whole number mark that merited the award of an A grade in English. So just remember again that in English we had mu, the average here, the average mark was 72, the standard deviation was 10. Okay, So we've got to work out what minimum mark will merit an A grade. So let's see, we need to look at the probability that, well, if I draw it first actually, and then I'll just write that down. So if we draw our standard curve again, and our standard normal curve, we are looking at some z value here, let's call it z1 up here, such that this area here will be let's see, what are we talking about, 15%. So this will contain 15% of the students, so 15% will be up here. So that means, so this is your 15% here, so that means 85% will be down here. So if we look at the probability that z is less than, we've got to work out what the z value here is, less than z1 will be equal to 0.85. So looking up or trying to work out z being greater than z1 equal to 0.15 is exactly the same as looking up or working out the probability that z is less than z1 equal to 0.85. So let's just look this up. If we look this up in the again in the tables, we can let's see, where if we look it up here, we're looking for 0.85. Somewhere in here we're looking for 0.85. So 0.85 is, let's see, 0.87, 0.86, 0.84. So 0.85 is here, 0.8508. I'm going to use this figure. You might be able to use some value between these two, but I'm going to take this one here, 0.8508. So that gives us a z value of 1.04. So let's have a look at that. So we have a z value of 1.04 here. So in other words, the probability of z being less than 1.04 will be equal to 0.85. We looked up to 0.85 and worked this out here, figure this 1.04 out. So now we have our z value, we have our z1 value here, if you like. How do you work out z values? Well, z values are just worked out by taking the x, subtracting the mean, which is 72 in this case, dividing by the standard deviation. We know that this z value is 1.04. Okay, so now all we've got to do is solve and work out what x is. Well, multiply across here by 10, you get x minus 72 is equal to 10.4, and then we're just going to add 72 to both sides, so that'll give me 82.4. So this is my x value. However, the question says find the least whole number, so you gotta score more than 82.4, but the nearest whole number greater than 82.4, the next greater number than 82.4 is 83. So they would have to score 83% minimum to get an A grade. Okay, so that's it for number 2. So let's have a look at number 3 here. Now, using the empirical rule, or otherwise, estimate the percentage of students in the class who scored between 52 and 82 in the English test. So in the English test, by the way, mu again is 72, the average was 72, and the standard deviation was 10. Now if we just have a look at standard normal curve again, look at the empirical rule here. So the empirical rule just talks about 1 standard deviation, 2 standard deviations, 3 standard deviations from the mean. So -1, -2, -3 standard deviations. And the 3 numbers you really need to be aware of when you're talking about the empirical rule are 68%, 95%, and 99.7%. So 68% of the data, of any particular data, will be within one standard deviation. So between this value here and this here, within here there will be 68% of the data. Between +2 and -2 standard deviations, within those two values there will be 95% of the data, and so on. 3 standard deviations, within 3 standard deviations there will be 99.7% of the data. Now we are told that the score here is between 52 and 82. Well, if we have a look at this here, if we take 72 as our mean, and we take 1 standard deviation, plus or minus 1 standard deviation, you're looking at 62 up to 82. 62 up to 82. And look, we have an 82 here. So 82 is going to be here. 82 at least is going to be here. So this is our x is equal to 82, if you like. Z value is 1. Now what about the 52? Well, we haven't reached 52 yet, so let's go to plus or minus 2 standard deviations. Well, take another 10 off here, so you're down to 52 now, and we don't really need to do this one, but it would be up to 92. But now we have our 52. We have our 82, which is plus 1 standard deviation, and we have our 52, which is 2 standard deviations below the mean. So these are the two values that we're looking at. Now we got to work out the percentage of students within this area here. Well, we know that we've got 68% in here. Got 68% of the students here. This is 1 standard deviation. And we know that we have 95% of the students within 2 standard deviations. So we've got to do a little bit of calculating just to work out what this blue value here represents. So let's have a look at that. Now we know we have 68% here. We have 95% here. So what I'm going to do is I'm going to work out the percentage that's in here and in here. So in other words, I'm going to take the 95% and I'm going to subtract 68%, and that will give me let me just work that out. So 98 minus the 68, that'll give me 30% here. Now, sorry, it's 95 minus, sorry, that's incorrect. 1 second now. We've got the 95 minus 68. 95 minus 68, that's 27. Sorry, 27. So in other words, 27% of the data is, let me do that in a different color here. So 27% of the data is here. It's the green color here. 27% of the data is in there. Now, because this curve is symmetrical, I can divide this 27 by 2. So 27% divided by 2. That'll give me 13.5. So in other words, I know 13.5% of the data will be in here. So I know that this here is 68%. The blue area here is 68%. I have 13.5% in here. So I've got to add these two to give me the percentage of students that are in this blue area and this part of the green area here. So all I've got to do is take 68%, add the 13.5%, and that'll give me 81.5%. And this is the percentage of students in the class who scored between 52 and 82. So this is equal to the percentage of students in the class who scored between 52 and 82%. Okay, so that's it for this question.